2.6 special functions. We're going to do this again today, each of the three different types, and then you'll have some problems you can work on before you leave. You'll get a few minutes before the bell goes off to start on them. Greatest integer function. F of x equals 3 times the greatest integer of x minus 2. From the homework review, you should have learned that this graph is going to stair-step up, and it's going to increase upwards by how many each time? By 3, because you're multiplying the greatest integer by 3. So let's see if that holds true. Let's plug in a negative 2. 3 times the greatest integer of negative 2, close the negative or greatest integer, and then minus 2. Greatest integer of negative 2 is negative 2. So 3 times a negative 2 is negative 6, minus 2 is a negative 8. We put in a negative 2 and came back with a negative 8. Now, of course, that's because we had the greatest integer of negative 2, and you're still going to get a negative 2 no matter what you put in between here and here, but not including this, the negative 1. Negative 1 1/2, negative 1 1/4, whatever comes back is still going to take you this far down to negative 8. So it's going to go from there over to here, make a dot. So let's go over 1. Instead of plugging in negative 2, let's plug in negative 1. 3 times the greatest integer of negative 1 minus 2. The greatest integer of negative 1 is negative 1. Times 3 is going to be a negative 3. Negative 3 minus 2 is a negative 5. So I plugged in a negative 1 and came back with a negative 5. And whatever I put in between negative 1 and up to and not including 0 is still going to take me this far down. So I'm going to go over and not include the 0. Yes, this went up by 3. From here up to there, that is 3. This is negative 8, this is negative 5. At what y-axis level should the next step be at? Negative 2. It should be at negative 2. So it should be here, and we would be plugging in a 0 for the next integer. So it should be there, and then you go over, open dot. And you can finish this one out. Up 3 from there is going to put us at 1, and then over, open dot. Up 3 from there is going to put us at 4. And there's your greatest integer graph. Piecewise functions. F of x equals a negative x plus 3 if x is less than negative 2. F of x equals a half x minus 2 if x is between negative 2 and 2 inclusive. And f of x equals x plus 4 if x is greater than 2. So find your boundaries first to know what you have to deal with. Here is going to be a negative 2. So we'll make a line straight up and down, and we'll move it to here. There's negative 2. Let's make another one for the positive 2. So there's your 3 sections. And you know the first one is negative x plus 3 if x is less than negative 2. So let's find the graph of negative x plus 3. Plus 3 means it's going to cross the y-axis there if it went all the way through. And it is a negative 1 slope. So you would go down 1 over 1. But that's not the direction we want to go, so we'll take it back the same pattern going this way. And then we can draw a line through there. We'll make this one blue. And that should be close. Just a little bit off. And it's an open dot because you're not going to include that. Then look at the middle section. A half x minus 2. So we go to negative 2 here. The slope is a half, so you go up 1 over 1. That's the same as down 1, back 2. But either way, you've got enough points to make your line. And we'll go like this. Those are closed dots because they can include those. And then the last one is x plus 4, and it's got to be to the right of 2. So we will go to 4 and make a dot. The slope is up 1 over 1. So we'll just carry that one out all the way through here. And here is the line. There is your piecewise function. This one would be an open dot because it does not include the positive 2. It must be greater than that. Graph an absolute value function. F of x equals the negative absolute value of x plus 2. Close the absolute value and then add 1. When you're looking for your values, you should choose stuff that's on either side of 0. One possible choice would be negative 3, negative 2, negative 1, 0, 1, and 2. And plug in each of those to come up with your points until you can find the V shape. If you don't reach the vertex of your graph even after 5 points, then you're going to have to plug in more points and carry it on. Maybe negative 5, negative 4, positive 4, positive 5. So let's plug in negative 3 and see what happens. So f of negative 3 would be negative absolute value of negative 3 plus 2, close the absolute value, and then plus 1. Negative 3 plus 2 is negative 1. The absolute value is 1. But that negative sign on the left outside the absolute value brackets is going to make it negative 1. And if I do negative 1 plus 1, then I come up with 0. So I put in a negative 3 and came back with 0. I'll try negative 2. F of negative 2 is negative absolute value of negative 2 plus 2. Close the absolute value and then plus 1. Negative 2 plus 2 is 0. Absolute value of 0 is 0, and a negative 0 is still 0. So I come back with 1. I plugged in a negative 2 and came back with 1. I'll put in a 1 or a negative 1 next. So f of negative 1 is negative absolute value of negative 1 plus 2. Close the absolute value and then plus 1. Negative 1 plus 2 is 1. Absolute value is 1. The negative sign outside makes it negative 1. So now I have negative 1 plus 1, which is 0. I plugged in negative 1 and came back with a 0. Whenever you see the change, notice you had negative 3, 0, and then negative 2, 1, and then you put in a negative 1 and came back with another 0. That means you have changed there. Your vertex has been found. The number that's in between the two that are the same there, the exact middle, will more than likely be the vertex. So we can go through and look at that and plot what we have so far. And I'll make it a bigger dot. I'll choose this and this. So negative 3, 0. If I go back 3 and up 0, I am here. Back 2 and then up 1. And then negative 1, 0, so back 1, up 0. There's the V shape right there. So once you have that, you can go ahead and graph. We'll choose to use black. We'll go this way. See if we can make that work. Yes. And then the other way. There's your absolute value function.